about chronic kidney disease, and I think the regular course of this year will be in May.
Yes.
Am I right?
Yes, it will be on the 15th of May, from 15th to the 17th of May, and it will be in Cairo, and we have 10 grants for accommodation for anybody from outside Cairo, whether Egyptian or non-Egyptian, from outside Africa, of course. Anybody from outside Cairo, we have 10 accommodations, but you have to register as early as possible. The details are on the website. It's called www.4ckd.blogspot.com. 4ckd.blogspot.com.
So thank you, Dr. Muhammad, for all these activities, and today Professor Mansoura will give us a talk about what's new in era of protein-bound uremic toxins. And I asked him to just give us idea about the academic points and then to give us teaching points from practical points at the end of the presentation. Professor Mansoura.
Thank you very much, Professor Hussein, for inviting me and for this very nice introduction. I'm always very glad to be in Mansoura because I have so many friends here. Of course, Professor Shaisha is one of my best friends, and I'm also very, very glad to see you all here. Because even though we are neighbors, we don't get in touch with each other that frequently. So I just need to ask, where are you from? Which countries are you from? Zambia? South Sudan? Gabon? Okay, so you're from all over Africa. Anybody from Nigeria?
We have guests from 13 countries.
13 countries.
13 is really
Beautiful.
So, but okay. I ask you just to be slow in pace.
Okay, I'll do that.
To allow the translation.
Okay, so we'll be talking about what is new in the era of protein-bound uremic toxins. Of course, it sounds very academic, and we will start academically. But then we will move slowly until we see how important it is from a clinical point of view. We will be talking about the updates. So before we go into the updates, we need to know what we knew from before. What are the old things that we knew? This is the oldest thing I could find from the literature. This is an article from 1888. It was a presentation, pretty much like this one, about uremia. And the author says a very beautiful quotation here. Uremia, he's trying to define uremia, is a disease, may be defined by the altered condition of health caused by the accumulation of poisonous products that should be removed by the kidneys. That was the definition in 1888. Interestingly, this is a paper from 2012, and the definition is, again, uremia is characterized by the retention of various solutes that should be excreted by the kidneys, and these solutes may interact negatively. When they interact negatively with our body and our tissues, they become called uremic toxins, and they cause the uremic syndrome. It's just the same, but a different way of saying it. It's just exactly the same definition that we had 130 or 140 years ago. But now we do know a little bit more. So, for example, we know that not everything that is retained, that should be removed by the kidneys and is retained in the blood of patients with uremia, is a toxin. We call them retention solutes. If those solutes have a negative effect on health, they become called uremic toxins. And to call them a uremic toxin, you have to know exactly what you are talking about. So you have to have a chemical characterization of the toxin that you are talking about. You should be able to measure it. You can't just talk about any dream. It should be a measurable toxin. Of course, this toxin has to be higher in uremic patients than in non-uremic patients. And there should be evidence that this particular toxin is associated with some of the negative symptoms and signs or manifestations and complications that we have in uremic patients. This should be shown clinically, it should be shown in the lab and in vivo or in ex vivo experiments. So this is the new definition of uremic toxins, a little bit like what we had 140 years ago, but with a little bit more details. interestingly, again, from the same paper, I really like it because it is, if you look, I really do advise you to read this paper. You can get it on PubMed. It is so interesting to see how 100 or 200 years ago they were able to reach so precise conclusions with very little tools. And look at this quotation again. He's trying to figure out where the source of the toxins came from. And he started by talking about stuff that we take from outside our bodies, particularly potassium. And then he talked about stuff that comes from the disintegration of the tissues, metabolism. And he also talked, interestingly, about number 2, the absorbed products of the intestinal putrefactions. Putrefaction, by the way, is the decomposition of proteins, not of anything else. And probably this is the only mistake that they have, is that they thought that the liver detoxifies those toxins by changing them and changing their chemical structure. Interestingly, the definition of uremic toxins in 2012 set by the UTOX group in Europe tells us that the source, that the classification of uremic toxins based on the source again is via endogenous metabolism, exogenous intake, or microbiotic metabolism. Microbiota are the bacteria that live within our bodies, especially in the intestine. Based on their characteristics, on how you can remove them by extracorporeal circuits, we have small water-soluble solutes, we have middle molecules, and we have protein-bound molecules. Today we will be talking about the toxins that are protein-bound, and they also happen to be products of microbiotic metabolism. If you need to know any further details, those 3 sources at the bottom of the slide are very interesting, and they have lots of information in them. So, today I'll be talking mainly about 2 toxins. One of them is derived from the indole ring, it's called indoxyl sulfate, and the other is derived from the phenol ring, and it's called the p-cresyl sulfate. This is how p-cresyl is formed. So we start by amino acids from proteins like tyrosine or phenylalanine that become putrefied by bacteria to form something called p-cresyl. This is an effect of the metabolism of bacteria on the proteins that we eat. P-cresyl is then changed in the liver to something called pre-cresyl sulfate. This was thought to be a detoxification, but in fact it's not a detoxification. This is intensification of the toxicity. Because p-cresyl by itself, produced by the bacteria, is not very toxic. But when you add sulfate to it, it becomes p-cresyl sulfate, it becomes very toxic. And more recently, a very recent day, is they also found that if glucuronidation, if you attach a glucose molecule to the p-cresyl, it also becomes toxic. It becomes p-cresyl glucuronide. The other toxin, indoxyl sulfate, is formed in a very similar way, but you start with a different amino acid, tryptophan, and it's formed by E. coli in the GI. This is a very interesting study because it proves this concept. It proves what was said 140 years ago, that many toxins are formed in the intestine from the microbiota, and it proves what I was just trying to show you, that indoxyl and cresyl sulfate are formed in the intestine. In this study, they took a few patients who were on dialysis who had a colectomy for any reason, because of cancer, colon, inflammatory bowel disease. They don't have a colon, they have renal failure, and they're on dialysis. And they measured the level of indoxyl sulfate, p-cresyl sulfate in those patients, and they found that the levels of those toxins were extremely low, the one in the middle, very low, because they don't have a colon. They're even lower than normal individuals with normal kidney functions. But of course, if you look at those at the far left, dialysis patients with a colon, they have a very high level of the toxin. You take out the colon, and they don't have those uremic toxins. So this proves that yes, without a colon, you don't have those toxins. So what do those toxins do eventually? Well, we'll be talking about three things that they do. They can cause inflammation. They can cause kidney damage. So we're not talking only about dialysis patients, we're talking also about pre-dialysis patients, and they can cause cardiovascular damage. This is an interesting in vitro study on granulocytes. So they bring some white blood cells, neutrophils, they put them in a dish, and then they add to them. Do I have a pointer? Is this a pointer? Dr. Hussein, a pointer? Sorry. I don't know. Okay, so these are the neutrophils. You don't add anything to them. If you just add p-cresylglucuronide, there isn't much of a difference. But if you add